Dear students, today I will discuss the question I have posted on the classroom, that is working of instruction queue in 8086 microprocessor. Instruction queue is very important part of 8086 and it lies in bus interface unit of 8086. What is its function? Instruction queue can store 6 bytes of data and it is used to store 6 instruction codes. These instruction codes are pre-fetched in the bus interface unit before giving it to the execution unit. So due to availability of this queue, pipeline architecture in 8086 is possible. So to understand the working of instruction queue, first we have to understand what is pipeline architecture and why it is beneficial or why it is helping in the increased speed of 8086. As we know that any instruction cycle can be divided in 3 time slots. We can write instruction cycle is equal to fetch cycle plus decode cycle plus execution cycle. Any instruction execution can be divided in 3 parts: instruction fetching, then decoding, and then execution. So to explain the advantage of pipelining, I am going to explain the time required to execute 2 instructions with pipeline architecture and without pipeline architecture. Time required to execute 2 instructions with pipeline and without pipelining, so that we can compare their time periods and we can show that how pipeline architecture can reduce the time required for the execution of any instruction. Okay. So first I will explain the time period required for the execution of 2 instructions. Suppose that there are 2 instructions and their time slots can be shown as F1. One instruction cycle can be divided in 3 parts: F1, D1 and E1. Similarly, second instruction's timing can also be divided in 3 parts: F2, D2 and E2. So this is complete time required for the execution of any instruction in a normal processor which doesn't have pipeline architecture. This is the time required without pipeline architecture. Now I am going to show the time calculation or time demonstration for 2 instructions execution with pipeline architecture. So as we know that in pipeline architecture, what will happen? Fetching and execution. Fetching is a process that can occur in bus interface unit, while decoding and execution can occur in execution unit. Any instruction cycle is divided in 3 parts: fetching, decoding and execution. Here fetching occurs in bus interface unit, while decoding and execution occurs in execution unit. Okay. So if we consider the pipeline architecture, the time calculation using pipeline architecture, so here fetching is a process which occur in bus interface unit. So this is first instruction which is being fetched. It is in BIU. When first instruction is being fetched, in bus interface unit, then it will be given to execution unit. So after the fetching of first instruction, it can be decoded and executed in the execution unit. Decoding and execution can be done after the fetching of this instruction. So this process will occur in execution unit. So when the first instruction is being decoded in execution unit, second instruction can be fetched in the bus interface unit at the same time. So these two events are in parallel. Fetching of the second instruction while decoding of the first instruction. So these two processes are in parallel. Similarly, when the first instruction is being executed, then the third instruction can be fetched in the bus interface unit, and so on. So here in bus interface unit, what will happen? Fetching of the instruction occurs, and in execution unit, what will happen? Decoding and execution process occurs. So after the first fetch cycle, these two processes, the work of bus interface unit and execution unit, occurs in parallel, so that if we consider the total time required to execute two instructions, here the first instruction is completely executed. Now decoding of second instruction and execution of second instruction occurs. So in this time slot, you can see that complete and two instructions are being executed, and this remaining time, this is the time which is saved. How it is saved? As you see that without pipeline architecture, if we don't use pipeline architecture, then the total time required is this, from here to here. And if we use pipeline architecture, then the time required for the execution of two instructions is this. Let it is T dash. The time required without pipeline architecture is T, and time required with pipeline architecture is T dash. So from here we can see that T dash is less than T, and the difference in these two time slots is this, which is time saved with the help of pipeline architecture. So this saving of time is possible due to the parallel processing of bus interface unit and execution unit, and this process is known as pipelining. So with the availability of instruction queue, pipeline architecture is possible, which saves much of the time and which increases the speed of the processor. Okay, so when you have to explain the function of instruction queue, the instruction queue is what? Instruction queue is a instruction queue is a 6-byte register, is a set of 6-byte registers which lies in the bus interface unit, where the pre-fetched instructions are placed before giving it to the execution unit. Due to availability of pipeline architecture, instruction queue can save much of the time and increase the speed of the processor. Thank you.